All right, today we're going to talk about the distributive property. There's a product of real numbers called the distributive property, and in this property, it's related to multiplication with addition and subtraction. We don't use this property in math because we can usually compute what's inside the parentheses first. But in algebra, we can't always do what's in parentheses first because sometimes the terms that are in parentheses are unlike terms and we can't combine those terms. Therefore, we have to use the distributive property, which tells us to multiply anything that's touching the parentheses times everything inside the parentheses, and that gets rid of the parentheses. So let's use the distributive property to simplify each expression. Okay, so if we look at this first expression, just like I said, sometimes the reason why we use a distributive property in algebra is because we can't do order of operations and combine the stuff in the parentheses first. X plus 2, we can't do that. They're not like terms. So to get rid of the parentheses, we're going to use the distributive property and distribute the 4 into the parentheses. And when we do this distributive property, we're multiplying whatever is outside the parentheses times everything inside the parentheses. And it helps to make those little marks just so you can remember to do that operation. The most common mistake is a student will multiply times the first term and then they'll just bring down the second term without multiplying. So make sure you multiply times every term in the parentheses. Okay, now we cannot add or subtract terms that are not alike, but we can multiply terms that are not alike. So if I multiply 4 times x, that's like a 1x. So 4 times 1x would just be 4x. And then 4 times 2 would be a positive 8. And then I'm done. I can't do anything else because those are not like terms. But this is simplified and we're done with that problem. Okay, so let's go on to B. Again, I'm going to distribute 3 times x would be 3x. 3 times negative 5, a positive and a negative, that's negative 15. Now, if there's a sign in front of the number, that has to go with the number. That's a negative 7. So negative 7 times 4x, that would be a negative 28x. Negative 7 times positive 3, that would be a negative 21. All right, here again we have a negative number. Negative 3 times x, negative 3x. Negative 3 times negative 7, negative times negative, that's positive 21. For E, we have 5 times 2x, that would be 10x. And then 5 times 7y, that'd be plus 35y. Okay, for F, we just have a negative sign in front of the parentheses. That's the same thing as a negative 1. So if I multiply a negative times positive, that would give me a negative 6x. A negative times negative, that would be a positive 3y. Okay, we have some fractions here in the next problem. So if I'm multiplying fractions, I can change the whole numbers to fractions. So I could say this is over 1 and this is over 1. So remember, I multiply the top times the top and the bottom times the bottom. So that would be negative times positive, that's negative. 1 times 8 is 8. 2 times 1 is 2x. Well, that was to the first one. Then negative times negative, that's positive. 1 times 4 is 4. 2 times 1 is 2. And then that would reduce to negative 4x plus 2. Now, let me show you a little trick. Anytime we're multiplying times 1/2, we're actually taking half the number. So I could have just gone straight to this step if I just took half of each number. Half of 8 would be 4. And of course we have to figure out the signs. Half of 4 is 2. So that's just a little shortcut if you'd like to do it that way. Now that only works whenever the numerator is a 1. So if it's 1/2, we're taking half the number. If it's 1/3, we're going to be taking a third of the number, or really dividing by 3. But that only works if the numerator is 1. So we can't do that in this next one. Again, I can change these to fractions. If I multiply by 2/3, 2 times 2, that's 4y. 3 times 1 is 3. And then 2 times 7 is 14. 3 times 1 is 3. So then we want to make sure, see if we can reduce either of those. And we could change those to mixed numbers, but we don't need to do that. We just need to make sure it's reduced. And those two fractions are both reduced. Okay, so then in I, we could take the shortcut, and since this is a 1 on top, we could really just divide each one of these by 5. But I'm going to go ahead and do it the long way because I don't want to confuse anybody. Okay, so -1 times 10x, that would be -10x. 5 times 1 is 5. -1 times -25, that would be +25. Over 5 times 1 is 5. Okay, so then I would reduce that, and I would get 2x plus 5. So again, see, I could have just divided each of these by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. All right, now, in J, we have 3 terms inside the parentheses. And it doesn't matter how many terms we have inside the parentheses. Anything that's touching the parentheses, we have to distribute it to every term in the parentheses. So 5 times 4x, that's 20x. 5 times -y, that's -5y. And 5 times 3 is 15. And then we're done because all of those are not like terms, so we can't combine them. Now, sometimes once we perform the distributive property, we will have like terms. And if that's the case, we need to combine those like terms. So let's look at example 2 down here. In this first example, now we only distribute it whatever is touching the parentheses. So here this 4 is touching the parentheses. This 5a is not. There's a plus sign dividing it or separating it from that parenthesis. So I'm going to distribute the 4 into the parentheses, and I get 4a plus 8b. And then I just bring down this plus 5a. Now, do we have any like terms? Yes, these two terms are alike, so let's combine them. 4a plus 5a is 9a, and then I just bring down the 8b. Now I'm done because I combined the like terms. What would I distribute into the parentheses in B? I would not distribute the 11a or the -11a. I would distribute this negative, which again is understood to be a -1. Okay, so that -11a, I'm just going to bring it down. And then I'm going to multiply each thing in the parentheses times -1. Negative times positive b would be negative b. Negative times -2a would be a positive 2a. Now again, I combine like terms. -11a plus 2a would be -9a, and I bring down the -b. Okay, in example C, I have 2 sets of parentheses, and each set of parentheses has something in front of it. So for the first set of parentheses, what am I going to distribute? I'm going to distribute the 9. Okay, so 9 times a, that's 9a. Oof, that's a little crooked. Let me redo that. Okay, 9a plus 27b. Okay, then to the next group, negative times negative, that's positive 4a. Negative times positive, that's negative 18b. Okay, so now let's look for like terms. Here I have two a terms. 9a plus 4a, that's 13a. And 27b minus 18b would be a positive 9b. And then we're done with that one. Okay, for D, we have these fractions that need to be distributed into the parentheses. So I'm going to use that shortcut. Remember, if I multiply times 1/2, I'm just taking half of the number. So what is half of 12? That'd be 6x. All right, what is half of 6? It's positive times negative. That would be a negative. Half of 6 would be 3y. Now when I multiply times 1/3, I'm just dividing by 3. When I took half, that's dividing by 2. Here I'm taking a third, so I'm going to divide by 3. Okay, so 1/3 of 9, that would be plus 9 divided by 3 is 3y, and 12 divided by 3 is 4. Okay, do we have any like terms? Yes, we have two terms that are y's, but a negative 3y plus 3y would be 0. So those just completely go away, and I'm left with 6x plus 4. All right, for E, I need to distribute this 2/10. All right, so 2/10 times x would be 2/10 x. And then 2/10 times 8 would be plus, that would be 1.6, because 8 times 2 is 16, and we put back in that one decimal place, so it would be 1/6. All right, and then we have these two terms that are alike. Anytime I'm dealing with decimals, a lot of times it's easier to think about it if you think about it in money. So 2/10 would be the same thing as 20 cents, right? I just added a 0. And then 1/10 would be the same thing as 10 cents. So 20 cents minus 10 cents would just be 10 cents, right? A positive 10 cents x plus 1.6, and that would be my answer. So think about it in money a lot of times when we're dealing with decimals, and it helps. Okay, so we have the next two examples are in words. So F says add 3y minus 5 to y plus 16. So this is grouped together, and this is grouped together. So we're going to add this to this. Okay, so we got to start with the y plus 16, and we're going to add 3y minus 5 to it. Now, if I don't have anything in front of the parentheses, I can just drop the parentheses. And if there's a plus sign in front of the parentheses, that's just like a 1. Well, 1 times anything is just itself, so nothing changes. So that would just be plus 3y minus 5. Okay, so then if I'm going to combine like terms, y or 1y plus 3y would be 4y. And then 16 minus 5, that would be 11. Now in G, this is subtraction. Remember, we have to be careful when we're dealing with subtraction. It says to subtract 7x plus 1 from 3x minus 8. So we're taking this away from this, so we have to start with this second group. 3x minus 8, and I'm going to subtract 7x plus 1 from it. Okay, so this time, this doesn't have anything in front, so I can drop the parentheses, but this has a minus sign in front. So a negative times positive is negative. Negative times positive is negative. So we did have to distribute in this problem. Okay, so if I combine like terms, 3x minus 7x would be a negative 4x. And then negative 8 minus 1 is negative 9.